going to talk about exception handling. Exception handling is handling an error state in the program, an unexpected state. There are basically three kinds of errors. There are syntax errors, there are semantic errors, which are logic errors, because it's doing what you told it to do, but what you told it to do was wrong. And then there are runtime errors, like it couldn't open a file, or it divided by zero, or that kind of stuff. So that's what exception handling is for. You don't want your program just to crash because the user typed in something dumb. We do this. Int x is equal to 3. Int y is equal to x divided by 0. Print y. And this program is going to misbehave. It will crash. If it ever runs. I've done something to make it not run. Where's our output window? Where is our output window? Why are you giving me grief today? So when I run it, it says build failed, but what it really means is run failed. And here's why. Exception in thread. Arithmetic exception. Divide by 0. And if your Mars lander divides by 0 and the computer stops, then your Mars lander is going to crash. So we want to fix that so that that cannot happen. Well, it's telling us what we can do to fix it. Right here. We can catch this error. And if we catch this error, great. We can do something about it. So we need to put a try and a catch around this division statement. Try this. But since I know that it might, quote, throw an error, I need to catch an error. And the error is long and gnarly to type in. java.lang.arithmetic exception. And if we get that, we just want to print out the message. We're pretty sure that that's a divide by 0, so we'll put that as our error message. So we better initialize y to some kind of value so that we can print it out here. Alrighty, so I run it and it doesn't generate the error. I mean, we get an error, but at least we catch the error. The program continues to run. We could ask the user for a better value to divide by. So we could use this in some kind of loop in order to make sure that they don't divide by 0, that they enter some good data. We can use this kind of thing to make sure that people enter good data. Let's ask them for the value of an integer and then throw an error, or catch the error, if it's not a valid data. System.out.println, enter an integer value for 0, for z. Now we will read it in. We need a scanner. Z is equal to sc.next int. No, I'm not going to use int. That's cheating. Instead, I'm just going to use .next to read in a string, and then I'm going to try to convert it. Now, there's all sorts of problems here. I don't have a scanner defined yet. So above that, scanner sc is equal to new scanner, system.in. Import that. Okay, so we want to turn z into an integer. So z is equal to integer.parseInt, that string we just read in, and we're going to print out what we read. So it's asking me enter an integer for z. If I type in 10, great, z is equal to 10. What if I type in bad data? What if I think I'm using a float and I type in 10.0? It blows up, gives me an error here. java.lang.numberFormat exception. So I think I'm going to use a while true and then a break. And I'm not going to let them out until we actually get a good value. So while true, tell them enter an integer for z, read it in, and then z is equal to integer.parseInt, and then if they get that far, great, break out of the loop. This is the line that causes problems. We're going to have to put try catch around that. So try this problem code and catch the exception. Now I'm going to show catching the exception the easy way, or not really quite proper, but you don't have to give a specific error. You don't have to do java.lang.arithmetic exception. You can just do catch exception. That's the generic one. Catches all exceptions. Now we really don't want to do that, but I'm showing you that you can. If we get that exception, we want to print line an error message, invalid input. And we don't want to break there. We want to break only if we didn't get an error here. So we're going to put a break there. So now our code is while true, and inside the while loop, we ask for an integer, we read it in, and then we have a try catch. This is the problem code, so we try to parse the int, and if it's an error, it will throw an exception, which will be caught by this code, and then it'll loop. But if there is no error, then this will succeed and we can break out of the loop. So this is an input validation routine, and it can be written more than one way. We don't have to do a while true loop. We could make it, while invalid data, Boolean valid is equal to false, and then while not valid, do this, and then once we finally do get some valid data, we say valid is equal to true. Pretty much the same thing as our break. So let's test this and see if it works. Enter an integer for z, 1.0. Invalid input, enter an integer for z. Enter. Okay, we give up, we type some good data, and it says z is equal to 1. So it actually worked. We got some good data now. So this is an example of error handling, data validation. Using exception handling to make sure that the data typed in is valid. The reason you use this is because if you called next int and you don't type in an int, it's going to blow up the same way. And knowing how to convert something from a string to an integer is a very good thing, because you're not going to always have next int and next double and stuff like that. If you're reading data off the internet, you may not have those nice commands. You may just get a string of data, and then you have to convert it yourself. So now we've seen two sort of exceptions. Arithmetic errors and conversion errors. Now if you do this, if you do catch exception, if you do the catch-all like that, someday an employee is going to come and egg your car or something like that. In this particular case, it's pretty safe to do it, but what you're supposed to do is only catch the specific exception and not the generic one. The reason for that is that sometimes you can have code that'll produce more than one kind of exception, and you need to be careful about getting the right one. And if you get the wrong one, if you just catch all the exceptions, then you won't know which error triggered it. So we really should have been keeping track of what this specific one could have caught. The way I'm going to do that is I'm going to catch the wrong exception. You don't need to do this if you're following along, but I'm going to do this to get the wrong exception caught here. And then when I do it, I'll get back to seeing my error. So since I caught the wrong exception, then it still failed. It was no longer being caught. And here's the correct exception, java.lang.numberFormat exception. I can probably get away with just catching that and not adding java.lang in front of it, because everything that's inside java.lang is automatically imported into your code. So I can do this. I'm going to leave that catch statement there. It's not necessary, but just illustrate something. Okay, so now we're catching the wrong exception, but we're also catching the right exception. So it's not going to generate, it's not going to kill the program if I type in some bad input. So you can stack catch statements on each other, kind of like a whole sequence of if statements. If this error happens, do that, else if this error happens, do that. Problem is that if you catch the generic exception, gosh, I don't know. We don't know which one of those errors happened. We don't know whether it was an arithmetic exception or a number format exception. So like, let's do something dumb. Let's say s is equal to s divided by 0. That's dumb, but it would trigger an error. Excuse me, z is equal to 0 divided by. If that one blows up, we want to get the arithmetic exception. We want it to say divide by 0. If it can't do the conversion, we want to give it a different error. Not a valid integer. And now it won't even compile. It's saying arithmetic exception has already been caught. And it's saying number format exception has already been caught. And that's because I tacked this one on. If I really want to do that, if I want to catch all, I should put that at the end of the chain, because that'll catch anything that these won't catch. But in general, you don't want to do that, because if an unexpected state happens, you do want to know about it. You want your program to stop running, at least in test mode. So I wouldn't put that there. Okay, so now we're catching two errors. If one thing happens wrong, we're going to print divide by 0. If another thing happens wrong, we're going to print not a valid integer. There we go. Enter a number for z. I'm going to type in some bad data. It's not going to say divide by 0 because it didn't even get that far. It says not a valid integer. So if we debug it, we can watch it jump into that code. I'm going to set a breakpoint here and then do debug file. It's asking me to type in some data. I'm going to type in something bad. This is not an integer. And it runs down here. It ran here and it stopped because of my breakpoint. Then when I hit the step over line, it's going to try to execute that line that's highlighted in green. But it failed, and so it immediately jumped down into the catch that matched the error. And in this case, since it was invalid data, it's a number format exception, and it prints that out. Now we're at the end of our while loop, so when we click that again, it comes back up to the top of our while loop. It prints enter an integer. It reads the integer in once I type 1. I type in a 1. Now this is going to succeed, so it's not going to jump. That one actually works. But this division will not. That's going to blow up. And so it immediately jumped. It didn't get to execute that statement. Instead, it jumped here. And it's going to print out divide by 0. Then it's going to loop again. We still haven't got any valid input. We never will have valid input because either one or the other of those two things will happen. So I should have made this 1 divided by z rather than z divided by 0. Something like that to succeed. So that illustrates catching an error. There's one more piece of the try-catch, which I don't use too often, but it's called finally. you use finally to do something that's supposed to happen regardless of whether that happens or whether that happens. Even if this statement was a return to bail out of this method entirely, it will still execute the finally. So system.out.println, I guess we're all done. And I'm going to set the breakpoint again so that we can watch that happen. So what finally means is that it doesn't matter whether there were no exceptions or whether it caught one exception or another exception. It will execute this line of code before the last statement in the try block happens, or before it leaves the try block, however it was going to leave the try block. And that's kind of weird, because that means that it's going to do this, I guess we're all done, before it performs the return. So even though there's nothing between those two things, those two statements, we are going to see that happen. Let's debug it again. Enter a value for z. I'm going to just type in 0. We only need to prove that one error happens. All right, it's going to try to convert it, but that's going to succeed. I'm hitting step over. Now it's going to try to do the division, but we're going to be dividing by z, so we're going to get an error. So it caught it. It prints divide by 0, and then it prints, I guess we're all done. But we're not really done because we haven't exited the loop yet. So we're still in it. Now we're going to type in some non-erroneous data, like a 1. And the parsing will succeed. The division will succeed. Setting it valid to true is true. But before it actually processes this return statement to end our program, it's going to print, I guess we're all done. Then it leaps back to that return statement. That's like the weirdest thing in Java, the weirdest flow of control you can have. Then it bails out. So why do people do that? Well, sometimes, you may be opening a file and reading it, and you may want your finally statement to close the file, no matter what. Regardless of whether you caught an error or not, you want to close the file. Anything that needs to be done as cleanup, you might put in a finally. But really, honestly, I don't use it very often. I'm going to take that out of the example, take the finally out. And I'm going to leave it like this. So this is our example of exception handling where we read in data, we try to do some arithmetic. So what is our assignment going to be? Our assignment is going to be write a program that asks for two integers, x and y. The program then asks what operation to do, multiply or divide, based on this input. It will calculate z, which is either x times y or x divided by y, and print it out. But we're going to do this rock solid. We're going to use some exception handling. We need to be able to catch exceptions. So what do we want to do? Use exception handling to force them to type in good integers, and then use exception handling to not let the program crash if they try to divide by 0. So pretty much it's almost exactly what we have up here in our sample code. The program should not exit until I won't say that, but when I say use exception handling to force them to type in good integers, that means loop until they give us good data.